Hey students, hope you guys are doing well. Thanks for many of you that watched the video and did the homework yesterday. It's about 1 o'clock today on Wednesday, and I've already been getting a lot of your assignments in, so thank you for that. What I want to do today is take you through level 3, bullet point number 1. So if you look at your rubric, I'll read that here quick. That says, students can explain the difference between linear and exponential functions and correctly interprets when each type of function should be applied. Section 5.3 in your book is where most of this information will come from. You need to read through that whole lesson. The book does a great job of explaining details and examples, so please look at that. What I want to do in this video is take you through Explore and Extend on page 283. This is at the very end of the lesson, and it asks the question, do either of the following tables represent exponential functions? Justify your answer. That's what we're going to try and accomplish. So before we get into that, we really need to understand what makes an exponential function exponential, what makes a linear function linear. So I upgraded today. I've got 2 whiteboards. I found another one. So this one even has all kinds of lined practice work. So I didn't follow it quite right. I probably wouldn't have gotten a good grade in elementary school, but it's okay. So just keep in mind these main differences. Linear have constant rates of change, right? That idea of a slope, the slope between one point and another point is constant. So if I were to draw that between these 2 points, linear, obviously, line, constant rate of change. Exponential has a multiplicative change, right? So between any 2 points, maybe this one and then one right next to them, you're multiplying by a constant to get from there to there. And the result when you do that over and over from one x to the next x and on and on and on, you get something more like this. Both of these our values were decreasing from left to right. So linear has a negative slope going down. This would be a decay exponential function going down like that, but it would still go through those 2 initial points there. So between any 2 points, you can have either a linear model or an exponential model, all right? And today, with that the Explore and Extend, we're going to try and figure out which is which based on a table of values. So, oh man, I had this all ready to go and then I just erased it on the backside. So bear with me a second. Okay, so here's the first table that they give us. So the question is this an exponential function? Well, in order for that to happen, it needs to have a multiplicative change from one to the next. Now the problem here, the reason why this one is a little harder is they don't give you constant changes in x's, right? If they gave you constant changes in x's, all you need to do is say, is it multiplying by a constant value to go from one to the next? Be pretty easy. This one's a little harder. So what we're going to do here is we're going to, ultimately I want to show you kind of a shortcut, but I want to explain the rationale behind that. So we want to see, does it fit into this general exponential function, right? So we're going to just pick any 2 values that are next to each other here. So just for right now, I'll pick these 2. And what we're going to do is we're going to say, all right, does it fit? Actually, let me back up a second. Many of you might recognize from yesterday's video that they give us an initial value here. So we could put 4 in for C. And then remember how yesterday, as we tried to figure out what that A was, we would pick some other value and plug that in for X and Y. So you could certainly do that. You could certainly take the point 2, 2.13 and put that in. Let me still see. you could put in the x for x and the y for y, and then you could go about solving. So I didn't do this ahead of time. So let me quick do the calculation. 2.13 divided by 4.5325 equals a squared. And then we'd have to, in this case, take the square root of both sides. And you get 0.730 equals a. So you could say between these first 2 points, we could write the function y equals 4 times 0.730 to the x. Now the question is, does that accurately model with the rest of the table? Okay, well, one way you could check that would be to plug in 5 for x and see if you get 0.83. 0.730 to the 5th power. So I'll do that to the 5th power times 4, and I get 0.83. Okay, so far so good. Let me check it with the next one. Let me plug in 10. Y equals 4 times 0.730 to the 10th power. Times 4. I get 0.17. So it really is indicating that it looks like this really fits with that exponential function that we came up with. Okay. Now, I want to show you another way to check this, probably a little faster way. This is kind of a long way to actually come up with a function. We actually weren't required to come up with a function from the problem. So let me show you a shorter way. Hopefully you've been able to see this okay. All right, so here's the shortcut. You can recognize, let me go back to taking these two, and I'm going to kind of expand that. So I'll still have kind of my table here, but I'll put 2, 3, 4, and 5 down. We already know what 2 is, 2.13, and 5 is 0.83. And we obviously don't know what 3 and 4 is, but because it's exponential, we know that the factor that it's multiplied by each time has to be the same. So there's got to be some number, that's our in this case decay factor, that's our a in our basic exponential function, that gets multiplied each time to go from one to the next. So there's some a here that we have to figure out. All right. And so what you can do as a shortcut is you can say, you can take the lower value, 0.83, you can divide it by 2.13, and that ratio, let's see, actually taking the third root, which basically comes from taking the 5 minus the 2. Sorry about that. So the index of your square root comes from the difference in your x's, and what's underneath the square root comes from the ratio of the further value divided by this first one here. So when you do that and you type that in, remember to get this here, if you want the third root in your graphing calculator, you can type in 3 and then go to math and then arrow down. I think it's number 5 under the first one. That'll give you the third root of 0.83 divided by 2.13. And that will give you, make sure you get parentheses around that. You guys probably have newer graphing calculators than I do. But this gives you 0.73. Okay? And that is the a value that we came up with doing it the other way. This is just another way of doing it. Maybe a shortcut for some of you that like shortcuts. If I were to do that for other ones, maybe I could do it between 5 and 10. So that same method would say, all right, take 0.17 divided by 0.83, 10 minus 5 gives you the index. So in this case, it's an index of 5. So I'm going to do the fifth root. The fifth root of, put in parentheses, 0.17 divided by 0.83. And I get that same value of 0.73. So if you're getting that constant value, that would indicate, hey, no matter which 2 points I look at, if I'm thinking about it from an exponential standpoint, we get 0.73. We get the same a value, so it must be exponential. I'll leave it at that for now. Some of you might be wondering, where am I coming up with this? Maybe I'll leave you to that to think about a little bit. Basically, you can go back to this formula and derive that, okay? But for now, I'll just leave it at that. I'm trying to make my videos a little shorter, but that's not working at this point. We're already at 11 minutes. It took me an hour to upload my 12-minute video last time. If any of you have ideas for making that go faster, that'd be great. Here's the second one. If we do the same thing to see if it's exponential, you, again, just pick out 2 of them. Doesn't matter which 2 you pick. Start with that, right? To go from 0,3 to 212 in an exponential function. You could take 12 over 3. Notice this is going to be a growth function because it's getting bigger. And we're going to do the square root of that. The question is that the same as, I don't know, maybe pick 5 and 10. 48 over 25.5, and then the fifth root of that, because 10 minus 5. So if you check both of those, I believe this comes out to be 2. And if you check that one, I thought I had it checked. 48 over 25.5. The fifth root. You get 1.13. And obviously, since those are not equal, this is not an exponential function. Okay, close but not quite. All right, so that's what I've got for you today. Please do the problems that are listed. Keep working hard and keep bringing me your questions. I'll do my best to get back to you as quick as I can. Thanks.